Hello everybody, it's Jonah Computer Scientist here, and today I'm going to go over a little bit of recursion with you guys. I honestly wasn't going to make a video today, but I looked at my YouTube Studio app and then I saw that actually I got a comment from Joe Ice. So this one is literally because Joe Ice said, "Come back, man." So I'm here. I went over recursion before, but I have a much deeper understanding of recursion because we keep talking about it in class. If I don't understand recursion right now, it's like, why am I a computer science major? You get what I'm saying? So nevertheless, let's just hop on into Visual Studio and get this going. So essentially, I'm going to be making a program that takes two numbers. What are those two numbers, right? A base and an exponent, right? So 2 is 2 squared, 3 is 2 cubed, 2 is 6 squared. You get it. You get what I'm saying. Or even you could do power of 4. You know, it does everything. It's the computer itself. Now, the reason I'm doing this is because I really want to explain recursion to everyone. I think I can do it way better than I did in the past, so that's what I'm going to attempt to do. So the first thing we're going to do is make a prototype. I think that's what it's called. I kind of forgot. I hope it's called a prototype, but we're going to create this thing up here that says that I'm about to make a function, but we don't need it. I believe we don't need it. But then down here, we're actually going to create the function. This is how I learned it in class. So this is how I'm going to continue to do it for the rest of my life, probably. So I'm just going to do int x and y, because those are the two most basic variables that we always use in math, right? When you think of exponents, what do you think of, right? 2 plus 2 plus 2. I'm not plus, times. 2 times 2 times 2, right? So that's what it is. Now this is going to be a recursive function. I said that already. Let's just say we have 2 to the third power, or 2 cubed, right? That's 2 times 2. Whoa, I don't know why I did that. 2 times 2 times 2. Okay, I can't type today. I can't do it. But that's 2 times 2 times 2. Now, we're going to run this function, and I'm actually going to type this out as I go. So we're starting off with 2. That's the parameter. This is the parameter, okay? Now, because this is the parameter, let's go. Actually, hold on. There's one thing we do need, though. So static int count equals 0. Let me explain this real fast. We just went over this in my programming languages class, and now that I understand what static does, I think it's cool. So before I made this program, I had a third variable, parameter up here called count, and then I set it to 0 every time that ran, but that made the function look ugly, right? Instead of doing that, you can just do static int count equals 0. This makes count the same variable in the memory. So when you do count plus plus here or somewhere else, it'll be that same thing. Whereas if I have int count equals 0 and then I do a recursive call, it's going to equal 0 again. You get what I'm saying? You're following what I'm putting down. I think you're following what I'm putting down. So static int count. Now this is crucial. I'm going to tell you why. Well, I'm going to tell you that now. So if count is equal to y, because if count is going to increment every time. So if count equals, like if 3 equals 3, then that means that we've multiplied it enough, okay? And I actually don't think this needs to actually, it might need to equal 0. I don't know. We'll see. I forgot. It's either 0 or 1. If I get the wrong output, then I'll just make it 1. I think it's 1 though. But actually it is 1. And it's 1 because, like, let's just say it starts at 1. So 2, and then it goes and it recursively calls 2, and then it recursively calls again 3, right? Now if it was 0, it would go again, which would be 2 times 2 times 2 times 2, and that would be 16. So it's definitely count equals 1. Now if count equals y, you're going to return x. We're going to return 2. So this equals 2, and then it multiplies itself by this, which then cancels that out and makes this equal 8, and then it's 8 times the parameter, which I'm sorry, not 2. Wow, 4 times the parameter, which gives you 8, right? You understanding me so far? So with that being said, that means that if it isn't equal to y, then, well, else, we're just going to return something else. This is x times, sorry, I had a brain lag, power x, and is it y or is it y minus 1? I think it's still x. I think it's still this. So anyway, let's just go into here and let's just see out, not count, see out that that pow 23, just to see if it equals 8, right? Power 23. I keep saying pow because it's already a function in here, but I just wanted to let you guys know that this thing is possible. It's a very cool thing that we can do. So 2, 3 as the parameters. What happens when we run it? Please run, please run. Oh, dang it. I didn't do count plus plus here. That was my problem. See, count never increments, so it never actually equals y. And then I have, I think it was something going on in the memory, I believe, if I'm not mistaken. I'm really bad at memory, by the way, and I'm learning it right now. I have to go over everything again. But anyway, you look at that. Oh, look, we have 8. So yeah, I kind of just explained it already. Like I explained it while doing the function. It increments, and then you do it once this equals, you know, x, then it's going to times itself by x, and it's going to continue to do it all the way back up. The recursive everything, and this works with everything. Seriously, see, look, do y'all know like 8 squared? What's 8 squared? Is that like 64 or something? It's like 8 times 8, right? I think it's 64. Hopefully it is, because if it's not, I'd be embarrassed. Yes, 64. I know 9 squared is 81. Yeah, oh yeah, 81. And we could also go to 4. I don't know what this is, I'm not gonna lie to you. So yeah, apparently it's 6,000. Let's just double check just to make sure. Okay, open it up. 9 times 9 times 9 times 9, 6,500. Hopefully it's not like reverse, because it's reversed to me, but yeah, and 51. So I wasn't even full screen when I did that, but hopefully you guys get the gist. If you do it yourself, you'll see it. Hopefully you guys understand recursion a little more. If you do, please blame me for that. I'll take full responsibility. But Adobe is about to start making me pay $50 a year, a month, for their services. And it used to be 20, and it went up to 30, and I was a little mad, but I kept doing it because it was just $10 more. But $20 more is ridiculous. So I don't know how long I have until I post another video. But hopefully I get to finesse this student account again and continue to pay 20, because I actually am a student, so I'm not lying. But yeah, thank you for watching my video. Don't follow me on Instagram. Don't follow me on, well, you can follow me on Twitter, but I'm thinking about deleting my Instagram. I'm having a good time without it. I'm on a little hiatus right now. Definitely subscribe to my YouTube channel. Hit the like button. Leave a comment, and tell me how you're doing in your computer science journey right now. You know, I'm technically a senior, and I just got a 90 on my midterm, and probably completely tanked another one, but I don't know. You know, we'll see. We will see. But I have high hopes for this semester, and I think I'm going to pass, hopefully, if everything goes right. And fall 2023 is still looking like it's in my radar. So that's me. Your turn. Tell me what's going on, and I'll see you in my next video. I'll try not to make it a long time from now. Thank you for watching.
I'm insecure still, and she's starting to notice. She think my feelings are bogus, but really she is my bonus. I don't like how I wrote this, because